For our group project presentation, Alexia, Sydney, and myself, Leslie, will be discussing the future of birth. Looking at the infertility statistics, around 11% of women experience infertility, while 9% of the world's population of men experience infertility. Although we do not know the specific percentages, there are some cases where both men and women are infertile. However, infertility is not the only issue. While some couples may not be infertile, they have a harder time conceiving due to a number of possible things. These are due to some conditions. As for men, some men experience azoospermia, where men produce a lower sperm count than normality. But fortunately, with this condition, they still have a good chance of conceiving a child by extracting sperm surgically. In the case of women, there is a condition called polycystic ovarian syndrome, where they have an immorality. They have female eggs may not be released regularly, or they can release unhealthy eggs. There's another case where there are age-related cases where women try to conceive a child during their later years, like late 30s to the early 40s. Some women try later when they're past their 40s. Typically, it's not recommended that these women do that because it can lead to Down syndrome. There's struggles for the LGBTQIA+ community to start a family. There's some parts of the world where the adoption and foster care it could be complicated or banned for the LGBT persons. There's where sperm donors and the lesbian couples, sometimes the pregnant partner has more rights to the child, or surrogacy for gay couples. Sometimes in the legal system, the birth mother can have more right to the child. This leads to the proposed solution where scientists have had the ambitious goal of creating artificial sperm and eggs with fertilizing abilities, but they've all looked into the same direction of using stem cells. But there's a debate on the type of stem cells that should be used, either embryonic stem cells or adult stem cells. There's also a variation on how to use the artificial sperm, whether it would work best to be injected into the testes or if it can fertilize an egg in vitro. There's each method and combination of methods have their own drawbacks and benefits, while they also have their own specific goals and target clientele.
The pop culture opinions. On the support side, most media sources view the new technologies put forth as a positive and discuss the benefits for all types of people and all possible uses of the new technology. A quote from Julia Compton for NBC News: "If creating sperm cells from stem cells or skin cells does become a reality, it could have a profound impact on some same-sex couples and heterosexual couples struggling with infertility." On the opposition side, other medias are skeptical and against the new technology. Some worry that men may become obsolete. Others worry about the possibility of forced parenthood. A quote from Jennifer O'Connell for the Irish Times: "This procedure is a long way off being tested on human stem cells, but when that day comes, it could mean that the end of men," a phrase coined by Hannah Rosin to describe in the end of the patriarchy, becomes a biological possibility. Glenn Cohen et al. For Stat News, in which gametes are created from cells secretly taken from an unexpected individual. Gathering stem cells. So when opting for the embryonic stem cells, they're extracted from embryos that are developed in vitro and donated to researchers with donors' consent. When they use adult stem cells, they're gathered from bone marrow by the use of a special needle that is inserted into the iliac crest, and up to about 1.5 liters of bone marrow are removed. Is removed, my bad, I'm sorry. Bone marrow itself contains stem cells that are responsible for creating blood, and once bone marrow is collected, the stem cells are removed from the bone marrow in a lab. Stem cells are used because they have a unique ability to differentiate into any kind of cell in the body.
In order to reprogram the stem cells into sperm cells, you must first produce fusion genes. The first two fusion genes contain green fluorescent protein and enhanced green fluorescent protein, respectively, as well as the promoter regions of murine STRA8. The last fusion gene contains red fluorescent protein and protamine 1 gene. All of them contain the neomycin phosphotransferase 2 gene, which is geared toward positive selection. After the fusion genes are created, they transfect mouse embryonic cells and allow the mice to grow, creating transgenic mice. They then collect bone marrow from mice, using femur flushing because they're too small to extract bone marrow with needles. They culture the cells in the presence of genotysin, which blocks polypeptide synthesis and helps selecting for STRA8, GFP, or EGFP positive cells. They use retinoic acid for induction, which is the ability for a cell to direct the development of other cells nearby, and retinoic acid is used because it's known for promoting developmental progression of spermatocytes in meiosis. Using fluorescent activated cell sorting, you can separate cells based on fluorescent characteristics they display and suspend them in liquid and inject them into a flow cytometer instrument. SSC7 and SSC12 lines can produce positive DS-red after retinoic acid induction. DS-red showing up is a sign that GFP positive cells are able to differentiate into male gamete haploid cells and are able to activate PRM1 promoter lanes in non-differentiating conditions. Reverse transcription polymerase chain reaction analysis is then used on both cell lines. Using flow cytometric analysis, it's found that a good percentage of the spermatogonial stem cell lines undergo meiosis in vitro with retinoic acid induction, but only a small percentage undergo meiosis without retinoic acid. It's known that methylation imprints are a quality demonstrated in the germline, so the methylation status was tested. Results show that some, if not all, methylation imprints had to be correctly reprogrammed for supernatant cells. Using your newly created sperm to fertilize an egg, you can use either in vitro or inject the sperm straight into the testes and let the mouse procreate on its own. The mice produce offspring at a success rate of about 18%, and of the successful 18% that were born, 50% typically display overgrowth. The other 50% is some ratio of normal growth and stunted growth. They also display methylation abnormalities, typically in spleen tissues, have respiration issues, and have a higher mortality rate than other mice.
Our objective thoughts. So objectively, the studies show that when creating artificial sperm, stem cells that have undergone retinoic acid induction have a higher likelihood of creating cells that undergo meiosis, and on a microscopic level can be seen as having more matured spermazoa. Overall, the success of creating artificial sperm is higher than the success of having viable offspring that have been fertilized by said sperm. The technologies for being able to create a viable offspring in mice still appears to be light years away and is even further away, speaking in terms of humans. Our opinions is that the idea of creating artificial sperm is a very fascinating concept, and the science behind it is clearly not child's play. We would love to live in a time where this kind of technology is successful and is not that expensive to replicate on humans. We think this is a revolutionary step towards equality for LGBTQIA plus community. We are pretty disappointed in our findings because most of the researchers behind it are strictly focused on the male side of fertility, although the media portrays it as being more geared towards the LGBTQIA community. And then our references. Thank you.